let's talk about rust and rust prevention. Okay, so corrosion is a general term that's given to metals that are being attacked by something and they're being eaten away. The metals are being corroded. Okay, it could be water, it could be an acid, but some kind of corrosion has taken place. Now you know that oxidation is what is it? Oil rig. Oxidation is a loss of electrons. So when a metal reacts, when it's corroded and it reacts, it's losing electrons. So the general equation would be that. Now that's if the metal's valency were 2. If it's 1 or 3, obviously you'd get M plus 1 E minus plus E minus, or M3 plus 3 E minus. So that's the general process. It's the opposite of extraction, isn't it? It's oxidation. Now, rusting is the oxidation of iron and alloys of iron. It's a very complex process and it's got lots of stages, but essentially the overall process is the iron reacting with oxygen to give iron oxide, which is rust. Okay, so rust is a specific word used for iron and iron alloys, such as steel. Now, the rust isn't quite as simple as this, but this is all you really need to know. A more complex equation would be this, where you form this iron 3 oxide, which is dot H2O. That's its water of crystallization. So water's involved in the process. Now this is important because for rusting to take place, we need these 3 things. We need iron, oxygen, and water. If we take one of these things away, rusting doesn't happen, which is why you can draw a rusting triangle, a bit like the combustion triangle. Here we need iron, oxygen, and water. If we take one of those sides away, rusting doesn't take place. Okay, so that's the basics of it. Now, if we want to prevent rusting, obviously, we need to stop water or oxygen from getting to the iron. So there are 2 general methods, coating or chemical methods. So we'll start with the coating. You put a layer on the iron or the steel, and that prevents the attack from water or oxygen or both. Okay? Typically we use paints. So we paint things like bridges and boats and bicycles. There's a bridge. This is from the Severn River. No, it's not actually. It's from the Forth River in Scotland. This is the Firth of Forth. This is the railway bridge, which is over 100 years old. And they paint it to stop it rusting. Obviously, rust isn't a good thing to have in a metallic structure, which trains are using. There's a nice story about this bridge that, I don't know if it's urban myth actually. I've been telling this for 30 years. And perhaps it's one of those things that people look up and say, well, it's not actually true, or it's not true anymore. But they say that there's a team that starts to paint the bridge from this end. And they've got all of the special kind of scaffolding and stuff, and they work all the way along the bridge, and it takes them 4 years to get to the other end. And then when they get to the other end, they might have a cup of tea, and then what do? They start again. Because it needs to be constantly painted, otherwise in these harsh conditions with salt water, and salt water actually accelerates the rusting process. In these conditions, you get very fast rusting, so you have to keep painting the bridge. Okay, so that's coats. You can coat the steel or the iron with paint. That's one possibility. You can use grease and oil, which not only keeps out the water, but also lubricates. There's a good example, a car engine or a bicycle chain. You can use plastic, again keeps out the water and the oxygen. Garden chairs and fences and wires and tubes. These are steel tubes coated in plastic. And also tin. You can deposit a very thin layer of tin onto the steel. This was the big breakthrough to make containers to keep food fresher for longer. Chromium can also be used. It can be deposited using electrolysis. And what that does is not only does it stop the steel from rusting, but also it makes things look nice. The chromium is very shiny. So you can see this on a Harley Davidson. You can see that they've covered everything with chromium and it makes it look really nice. So they're coating methods. Chemical protection. Well, the key idea here is that some more reactive metal, like magnesium or zinc or some alloy, when it's in contact with iron or steel, the more reactive metal will corrode in place of the iron. Okay, so you might have here an iron pipe. You connect it to a more reactive metal. It is sometimes called the sacrificial anode. And what happens is this magnesium goes into solution, this magnesium corrodes, and this process stops the iron from corroding. It kind of sacrifices itself, which is why it's called sacrificial protection. Every now and again, the magnesium anode will need to be replaced. Another possibility is galvanizing, where you dip iron or steel in zinc. This also leads to not only to the coating of the iron, which stops the oxygen and water getting through, but even if the surface is broken, because the zinc is more reactive, the zinc will corrode, will go into solution as Zn2+ instead of the iron. So it protects the iron, it sacrifices itself. Great places to use these things are quite difficult places to get to. For example, in the bases of bridges, in oil rigs, we've got magnesium blocks attached to the rig here, and it's attached electrically, so the magnesium sacrifices itself. But also on boats, these are sacrificial anodes, sacrificial electrodes on boats. So if you attach the magnesium, aluminium, zinc alloys, whatever they are, you attach them to the boat, and then they slowly wear away, and the boat is protected, the steel in the boat is protected. And then, every now and again, whenever you take the boat out of the water, you have to change them. They're replaced periodically. Another possibility, this has come up once I've seen in exams, is the idea of cathodic protection. And this is where you use electricity and you make iron or steel the cathode. And by doing that, the oxidation of the metal is inhibited. Very useful for underground or inaccessible structures. So if you've got a structure underground or in water, you can make it the cathode, and that stops it from reacting. So don't worry too much about all of these reactions. That's what happens. Okay, right, essential chemistry, some pages on rusting, and then you've got all of the end of chapter questions to try. I'll put the answers online for you to check.